In today's lesson, we'll be learning how to use the quadratic formula. The purpose of the quadratic formula is to find the values of x when y is equal to 0. In other words, it helps us find the x-intercepts, the zeros, or the roots. Remember, these three terms are synonyms, and this is the quadratic formula that we derived in the previous lesson. When using the quadratic formula, there are three possible scenarios. You can have two real roots. In other words, that means you have two solutions. In a previous lesson, we learned that these two solutions could mean something in real life. One of them may mean something in real life, or both of them may not mean anything in real life. In our second scenario, we have one real root. In other words, there is one solution. And our third scenario is when there are no real roots. In other words, there are no solutions. So as you can see, in the blue parabola, there are two x-intercepts. In the red parabola, there is one x-intercept, which happens to be also the vertex. And in our third parabola, the green parabola, there is no x-intercepts. So that means there are no real roots or no solutions. The discriminant is a part of the quadratic formula. If you look underneath the square root sign, you'll see b squared minus 4ac. That is the discriminant. If the discriminant is greater than 0, that means there are two real roots or two solutions. If it is greater than 0, that just means that it is positive. If the discriminant is equal to 0, that means there is only one real root. There is only one solution. And last but not least, if the discriminant is less than 0, that means there are no real roots and there are no solutions. In other words, that means the discriminant is negative. If the discriminant is positive, that means when you square root it, there are two possible values. There's a positive value and a negative value, which means you would get two values of x, which means you would have two real roots or two solutions. If your discriminant is equal to 0, this entire thing disappears and that only gives you one value of x. However, if your discriminant is negative, ask yourself this question: can I square root a negative number? And as of right now, you do not know how to do that, which means you would have no real roots or no solutions. If you have a quadratic relation in standard form, you can figure out the axis of symmetry just by looking at the values of a and b. So the coefficient of b would go into here, and the coefficient of a would go down here. The value of x would be the equation of the vertical line that goes through the vertex. In other words, that would be the axis of symmetry. The value of x also would represent the x-coordinate of the vertex. So if you have the x-coordinate of the vertex, you can always substitute that back into the quadratic relation and solve for y. In our first example, we want to use factoring to solve the quadratic equation 2x squared plus 9x plus 6 equals 0. In other words, we want to figure out the value of x when y is equal to 0. And as you can see, y has already been set as 0. So let's begin by rewriting the question. 2x squared plus 9x plus 6 is equal to 0. First off, let's look for a monomial common factor. So what is the greatest common factor of 2, 9, and 6? Well, the greatest common factor happens to be 1, so that doesn't really do anything. Therefore, we need to figure out two numbers when added together will give me positive 9, and two numbers when multiplied together will give me the product of 2 and positive 6. In other words, a product of 12. If you do a little bit of mental math, you'll soon realize that there are no numbers that add up to give you positive 9 and that multiply to give you positive 12. Therefore, you're going to have to conclude that, therefore, this cannot be factored. However, there is another tool that you can use to find the values of x when y is equal to 0. You can use the quadratic formula. In part B of the first example, we want to use the quadratic formula to solve the quadratic equation 2x squared plus 9x plus 6 equals 0. In the previous slide, we determined that we cannot use the technique of factoring. Therefore, we're going to have to use the quadratic formula. Let's begin by rewriting the question. 2x squared plus 9x plus 6 equals 0. At this point, I want you to take a close look at the values of a, b, and c. So here we have positive 2, here we have positive 9, and over here we have positive 6. Therefore, the value of a is positive 2, the value of b is positive 9, and the value of c is positive 6. The signs are very important, so please include them. So if these were negative numbers, you would have to include the negative sign. Now that we have our values of a, b, and c, let's go ahead and substitute them into the quadratic formula. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac over 2a. In the next step, all I'm going to do is I'm going to substitute in these values and I'm going to use brackets. You're going to have to be very careful here, and you need to use BEDMAS when simplifying. That's just going to be negative 9. 9 squared is 81. Over here you have negative 4 times 2 times 6. So negative 4 times 2 is negative 8, and negative 8 times 6 is negative 48. And at the bottom you have 2 times 2, which is 4. Alright, let's continue simplifying this. Negative 9 stays the same. Let's simplify what's underneath the square root sign. 81 subtract 48 is 33. You should realize that the discriminant is positive, which means there are two real roots. In other words, there are two solutions. Why are there two solutions? Well, if you take a close look at the square root sign, the answer is either going to be a positive number or a negative number. Okay, so I'm going to show you the two possibilities. So x could be equal to negative 9 plus the square root of 33 over 4, or x could be equal to negative 9 subtract the square root of 33 over 4. So there are two real roots, there are two solutions. Both of these answers would be considered exact roots because you're not converting them to a decimal and rounding them. Therefore, they're still exact. However, if you did want to round them, this would be approximately equal to negative 0.81, and this would be approximately equal to negative 3.69. Now, if you had a real-life situation or scenario, you would have to make sense of both these negative numbers to see if they actually mean something in real life. And there you go. We've just used the quadratic formula. And in this particular scenario, the discriminant was positive, which means we have two real roots or two solutions. In the third part of example 1, we want to determine the axis of symmetry and vertex of the quadratic equation 2x squared plus 9x plus 6 equals 0. As you can see, I've gone ahead and already graphed this quadratic equation. Let's just double check to make sure it makes sense. The value of a is positive, therefore the parabola should be smiling. In other words, it should be opening upwards, and it looks like it is. And last but not least, the value of c is positive 6, which means the y-intercept is positive 6. And as you can see over here, the y-intercept is positive 6. According to the previous slide, the x-intercepts should be negative 0.81. That definitely looks very close. And the other x-intercept should be approximately negative 3.69. And again, that looks pretty close. There is a shortcut you can use when trying to determine the axis of symmetry, but that involves you identifying the values of a, b, and c. Let's go ahead and do that once again. The value of a is positive 2, the value of b is positive 9, and the value of c is positive 6. Remember, the signs are very important, so please include them, especially if they're negative. The shortcut is x equals negative b over 2a. At this point, I'm going to substitute in my values of b. So that becomes 9 in brackets, and I'll have 2 in brackets. Let's go ahead and simplify this. So negative 9 stays the same. 2 times 2 is 4. Therefore, negative 9 divided by 4 is negative 2.25. Now, if you look back at the diagram, you'll see that an axis of symmetry of x equals negative 2.25 does look very reasonable. So let's go ahead and draw that in. Now, if you remember, the axis of symmetry passes through the vertex. So that means the x-coordinate should be negative 2.25. However, we still do not know the y-coordinate. Well, since you know the x-coordinate, you can substitute that value back into the quadratic equation and solve for y. So I'm going to do that quickly down here. First, I'm going to rewrite the quadratic relation, 2x squared plus 9x plus 6. Since you want to figure out the y-coordinate, all you do is sub x is equal to negative 2.25, and you just change all of those x values into negative 2.25 in brackets. Okay, and don't forget, you need to do BEDMAS when you're simplifying this. I'm going to skip through all the steps and go straight to the answer. The answer is negative 4.125. Now let's double check our diagram to see if that makes sense. And yeah, it does look very reasonable. So our vertex coordinates are negative 2.25 and negative 4.125. That is the coordinates of the vertex. So there you go. That's all the work that is required to figure out the axis of symmetry as well as the vertex.